Welcome you all. This is Suryakala working as an assistant professor in Sri Muthukumaran Institute of Technology. In this video, we are going to see the subject Embedded Systems and IoT, and the subject code is CS3691. In Embedded Systems, the fifth unit is the application development. In this video, we are going to see about the smart homes, smart cities, and the smart environmental applications of IoT. The outlines of these slides are IoT applications in home and cities environment. First one is the home automations. In IoT applications for smart homes are smart lighting, smart appliances, intrusion detection, smoke and gas detectors. First, see about smart lighting. In smart lighting, achieve energy saving by sensing the human movements and their environments and controlling the lights accordingly. Key enabling technologies for smart lightnings are solid state lighting and IP enabling light. Wireless enabled and internet connected lights can be controlled remotely from the IoT applications such as mobile or web applications. Next one is the smart appliances. In smart appliances, make the management easier and provide status information of appliances to the users remotely. Smart washers or dryers that can be controlled remotely and notified when the washing or drying cycle is complete. Open Remote is the open source automation platform for smart home and building that can control various appliances using mobile or web applications. It compares of three components. First one is the controller. Controller manages the scheduling and runtime integration between the devices, and the designer allows to create both configuration for controlling and user interface designs. And the control panels allows to interact with the devices and control items. Next one is the intrusion detection. In home intrusion detection systems, use security cameras and sensors to detect intrusions and trace alerts. The form of the alert can be in form SMS, email, image graph or short video clips and email attachments. And next one is the smoke and gas detectors. Smoke detectors are installed in homes and buildings to detect smoke that is typically an early sign of fire. It uses optical detection, ionization or air sampling techniques to detect smokes. The form of the alert can be in signal that sent to the fire alarm systems. The gas detector can detect the presence of harmful gases such as carbon monoxide, liquid petroleum gas that is LPG, etc. Next, we are going to see about the smart city applications. In smart cities applications, there are smart parking, smart lights for roads and smart roads, structural health monitoring, surveillance and emergency response. First, we are going to say about smart parking. Finding the parking space in the crowd city can be time consuming and forecasting. Smart parking makes the search for parking space easier and convenient for the drivers. It can detect the number of empty parking slots and send the information over the internet to the smart parking application, which can be accessed by the driver using their smartphones or tablets and car navigation systems. The sensors are used for each parking slot to detect whether the slot is empty or not. And this information is aggregated by the local controller and then sent over the internet to the database. Next one is the smart lighting for roads. It can help in energy saving. Smart lighting for roads allows lighting to be dynamically controlled and also adaptive to ambient conditions. Smart light connected to the internet can be controlled remotely to configure lighting scheduling and lighting intensity. Consume lighting configuration can be set or different situations such as a foggy day or festival day, etc. Next is the structural health monitoring. It uses a network of sensors to monitor the vibrant levels in the structures such as bridges and buildings. The data collected from these sensors is analyzed to access the health of structures. By analyzing the data, it is possible to detect cracks and mechanical brokens and locate the damages to a structure and also calculate the remaining life of the structure. Using such systems, advanced warning can be given in the case of immediate failure of the structure. Next one is the surveillance. Surveillance of infrastructure, public transport and the events in cities is required to ensure the safety and the security. Citywide surveillance infrastructure comprising of large number of distributed and internet connected video surveillance cameras can be created. The video feed from the surveillance camera can be aggregated in the cloud-based scalable storage solutions. Cloud-based videos analytics applications can be developed to search for patterns of specific events from the video feeds. Next one is the emergency response. In IoT systems can be used for monitoring the critical infrastructures, cities such as buildings, gas and water pipelines, etc. IoT systems for critical infrastructure monitoring enable aggregation and sharing of information collected from the large number of sensors. Using cloud-based architecture, multimodal information such as sensor data, audio, video feeds can be analyzed and near real time to be detect adverse events. The alert can be in the form of alerts sent to the public, rerouting of traffic or navigation of the affected areas. Next one is the environment. IoT applications for smart environments are weather monitoring, air pollution monitoring, noise pollution monitoring, forest fire reduction and river flood reduction. In wealth monitoring, it collects the data from number of sensors attached as a temperature or humidity, pressure, etc. and send the data to the cloud-based application and store back inside. The data collected in the cloud can be analyzed and visualized by the cloud-based applications. Weather alert can be sent to the subscriber users from such applications. Next one is the air pollution monitoring. IoT-based air pollution monitoring systems can monitor emission of harmful gases by factories and automobiles using gaseous and meteorological sensors. The IoT data can be analyzed to make informed decision on pollution control approaches. Next one is the noise pollution monitoring. Noise pollution monitoring can help in generating noise maps for cities. It can help the policymakers in making policies to control noise level near residential area, school and parks. It uses a number of noise monitoring stations that are deployed at different places in a city. The data on noise level from the station is collected on the servers or in the cloud, and then the collected data is aggregated to the generate noise maps. Next one is the forest fire reduction. IoT-based forest fire reduction systems use a number of monitoring nodes deployed at different locations in the forest. Each monitoring node collects measurements on ambient conditions, include temperature, humidity, light levels. Early detection of forest fires can help in minimizing the damage. Next one is the river. Thank you.